Welcome to the Maintainable Software Podcast, where we explore the art of improving existing software with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, Dr. Felienne Hermans joins us from the Netherlands. Felienne is currently an associate professor at Leiden University and is the author of the upcoming book, The Programmer's Brain: What Every Programmer Needs to Know About Cognition. Dr. Felienne Hermans, welcome to Maintainable.
Thanks for having me.
So as you reflect on your experience in the industry, what do you believe are a few common characteristics of well-maintained software?
So I think the most important thing about well-maintained software is that it makes it easy for me to look inside the head of the creator. So some people say code should document itself. And I think in a sense that's true. It's easy if you can read the code and see the story, but that isn't always possible. And specifically things like decisions, like why did you use a heap here instead of a list, right? You can see from the code how it works, but you can't really see very often from the code why it works in a certain way. And sometimes there are very good reasons for the use of a certain design pattern. And that's the type of code I like, where either in the comments or in an extensive README file, it makes it easy for me to understand, oh, this is why you designed it like this, because I guess you're familiar with this trap. I have certainly fell into this trap a bunch of times. Look at a certain open source project, you're like, why does it work like it? I don't think this is the proper way. And then you start rewriting a bit and massaging a bit. And of course, eventually you will run into the issue. It's exactly why it isn't designed the way you thought initially it should be designed. So that's, I think, the main characteristic. Is it easy to follow the thinking of the creator? Is it easy to understand why it works a certain way?
That's an interesting way to look at that. I often ruminate on what the previous predecessors on a project might have been like, right? And what were they thinking? What constraints were they dealing with at the time? How can you provide some sort of story to something where you have just some artifacts of the people that were once here before? So I'm curious, when you talk a little bit about thinking about how well decisions can be captured, and a lot of software is written by teams. So how does that kind of translate to what's the thinking of what a team did versus, say, an individual creator type of person, getting into the heads of a collective team that may or may not already be on the same page about what they're doing? Do you see much of a distinction there?
Yeah, that's a great question. So I think if you're designing or writing software as a team, it's even more important to have those decisions there, because if you do it for your own pet project, then it's nice if someone comes along. But in a team, it's even more important that as a group of people, you have this shared mental model of how the code works and why it works in that way. So of course it can be a bit harder to do this as a team, but then also even more it is important that there isn't the team, right? There is all the individual people. So it's important that individual people that work on the code all somehow document their intentions and their thinking in either write in the code base with comments or in design documents or maybe meeting minutes if you're in a little bit more formal setting. That is still, I wouldn't say it's a team. It isn't the team mental model. It is still a number of people that each make decisions and each have their own ideas about how the code should be working or why it works the way it works. So then I think the same holds, and it's even more important because you will directly benefit from it as a team, from the understanding of the whole team. Because if people understand why you did something in a certain way, that's not just something you do for them, right, for their understanding. That's also something you do so that they can align new code and new features with your way of thinking, that it fits your design. Because no one likes it if you made code in a certain way and then someone adds a feature and then it works, but they add it in a way you're like, no, that's not how you're supposed to do it. So the easier you make it for people to understand why it is the way it is, how it is supposed to be, the easier you also make it for yourself, because then your code will hopefully stay in that situation longer where it fits your own mental model.
I appreciate that. There's trying to capture your decision-making process. And I think developers or engineers in general or programmers are sometimes so focused on the current task at hand, and then being able to take that step back and be like, okay, how does this this change I'm making, how is this going to impact the bigger picture when I'm just, adding another field to a form somewhere? And it's kind of that get in and get out type of quick thing, but thinking about like, how do you capture and where can that information be captured and go back and be referenced? Sometimes I wonder about documentation and being good at commenting. Is how often does a team actually go back and lean on that ever and go back and read meeting notes from 6 months or 6 years ago? It's like we create a lot of information around the things we're doing, but sometimes the context of then doesn't always make sense now. Those people may or may not even be existing there. Have you seen some good patterns that teams can follow to not just document and capture that, but to also convey the value of having that? Because I've talked to a lot of people that think about documentation and they say it's important, but I don't hear a lot of people talking about how much time they spend reading, going back and referring to old documentation because they're worried it's outdated or not been maintained.
Yeah, that's a great question. And clearly it is really hard to maintain documentation. Also, just because it is less fun, right? It's just less fun than coding. I guess most people will agree to that. I think one thing I've seen that actually works quite well to maintain a shared mental model of code is mob programming. So where you do programming as a group, where one person, it's like pair programming, but then for n is more than 2. So there's one person is at the keyboard and another person is the navigator, but then another group of people can be a bigger size, is also contributing, is helping, is giving tips and suggestions, is saying, oh no, like don't do it like that. That's not how I intended it. So I think that's a great way to bring newcomers into a code base, firstly, but also to keep this shared mental model in a way that is, that's more programming than writing documentation, right? Because you're still programming, you're still adding features to the code base, so you will feel productive. Because I think that's one of the biggest issues where when people write documentation, they don't really feel that they're contributing. Sometimes also this is made worse by a manager or a supervisor who says, what feature have you made today? And not necessarily how many lines of documentation have you written. So if you do this pair programming or mob programming as a group, that helps you to keep an overview of the code without having to directly rely on documentation. That being said, of course, it is still also very important to keep your documentation up to date.
I think you just made a really good point there around whether or not the organization, the supervisors, product owners, if they celebrate or convey appreciation to doing those other types of tasks related to the code itself. So I think you're right. Like I've talked with people that are always trying to instill a certain level of like, hey, we should be celebrating more often when we're deleting code that's no longer necessary. And I feel like maybe another thing could be very true for like removing documentation that is no longer relevant, so that most of the documentation that you might accumulate over a period of time is actually currently maintained in a way that it's not leading people down. So that's like the worst thing for like someone coming into an organization and then be like, oh great, there's all this documentation, this is great, but then as soon as they start trying to use it and someone's like, oh, that's really outdated, I feel like it probably ends up sending a message like, well, nobody here really seems to take care of this stuff, so it's going to just continue being a thing. Like we capture stuff, but we don't maintain that as well. So
yeah, definitely. And that could also be like maybe the best scenario is if someone reads documentation, comes to you and says, hey, this looks weird. But then another situation could be where they read documentation, they think, oh, I see, this is how it works. They start programming, they start adding features, and maybe the first 2 or 3 actually work. And then they run into issues later on in maybe more complicated parts of the code base, because that is where the documentation was outdated. So yeah, people complaining about outdated documentation might be the least variant of that problem. It is even worse if people start adding features based on outdated information. Or if you are thinking of an open source project, that people look at your documentation and then tell the last commit on the README file, it's like 2017. Then people think, oh, maybe I don't want to commit here. I don't want to actively contribute to this repo because I don't know how to get started. So if you're an open source maintainer, then it can also be in your own. I'm talking to myself, really. It can also be really important to keep your documentation up to date so people can actually contribute to your open source project.
I can attest that that's very important to keep your README and your setup documentation, especially open source projects. I have a handful of them as well. And that's like, I feel like it's one of the areas of documentation I feel like I've done the best at, because I was like, because I don't get to like just have a conversation with someone on the team about if you can't figure something out, feel free to reach out to me. It's like, I think what a lot of teams will do. But when you're working in the open source community, you 90% of the time probably will never talk or interact with the person that may use that documentation. So you need to make that as useful as possible to a complete stranger. But I think that can also definitely apply to internally as well within any organization.
Yeah, because even in an organization, it is still, people are still reluctant, right? It's not great to reach out with the question, I don't understand what you did. That's just quite a high threshold thing to do, especially if it's people in the same organization, but maybe in a different team, or maybe you just don't know them so well. Even within your own team, you might have people that you are more comfortable reaching out to. So yes, it's very true for open source, but even within companies, just saying, if you don't understand, let me know. That is really a high threshold thing for people to, especially if you're in a team, maybe you're new, maybe you're just out of university, right? You're like, I want to figure out everything by myself. I don't want people to think I'm not so smart. Then it is not very likely that people will start complaining about the outdated documentation. It is more likely that they start, trying anyway and then failing and maybe messing up or just getting really sad and frustrated.
So I also want to pivot a little bit and talk about your book, The Programmer's Brain, what every programmer needs to know about cognition. So I'm a few chapters into it myself, and some interesting and fascinating takeaways from it. So I'd love to dig into a few of those topics if you're open to that. And first off, before we get into those, actually, what led you, Felienne, to feel like the person that should be writing this type of book at this point in time?
So the short backstory is I started to teach kids when I was just out of grad school. And these were like 10, 11, 12-year-olds in a community center on Saturday afternoon. And I was like, okay, I don't know anything about teaching, but they're kids, right? How hard can their questions be? And then I really failed as a teacher because they didn't remember anything. I told them, like, this is how a for loop works. And then 7 days later, they were like, how do you repeat something? It's like, well, you know that for loop I told you about 7 days ago once? Why don't you remember that? And that made me so interested about teaching and learning, because it was like these kids voluntarily come to the community center on Saturday to learn programming, and then they're not learning anything. Probably it's not them, it's me. So I need to learn more about cognition, about how people learn. So then, accidentally, this became my research area. So I've been teaching a course at the University of Leiden for a few years called Psychology of Programming, in which I explain to grad-level students what happens in your brain if you program. Is it different for your brain to read Python than it is to read APL, for example, or JavaScript? What do we know about the effect of memory, long-term memory and short-term memory on code? So I taught that course for a while, and then I thought, this is interesting for grad students, but this is also interesting for professional programmers, because my friends, people that I spoke to at conferences, many programmers, they aren't aware of even the basics, like the difference between short-term memory and working memory. So I thought, well, of course, this information is available in books, right? You can read an introduction to cognitive science book. This is many of the books I read when I started to explore this topic, but then they aren't so geared towards programmers. So some people, of course, might still be able to and be interested to read it, but then if you're a professional programmer, you might not just get the idea that there's something for you to take away there. So basically, my book is an introduction to cognitive science, but then specifically for programming. So all the examples about this is how your memory works are Java programs or Python programs, to give people a sense of what the influence is of their brains. And just the scenario we were just talking about, where you have code that is really confusing, that in itself already is something that my book sheds a new, deeper light on. Because if you are confused about code, there can be many reasons why code is confusing, and the book talks about that. So if, for example, you are programming in a new domain, imagine you've always worked in finance and now you go work in shipping, then of course code will be confusing because you just don't know the domain words. Whereas if you go to a programming language, maybe in a familiar domain, in a familiar programming language, then code can also be confusing because all the variable names are wrong or outdated, or they're all ABC or counter or object, or class, or we know those very generic variable names. And you can imagine that that's an entirely different type of confusion. Not knowing the domain words, the solution is knowing the domain words. If the code is very confusing because the variable names are very vague, then the problem is not you, then the problem is the code base. So there the solution is start to refactor, work with your team to improve your code quality in terms of identifier names. So if you understand why code is confusing you, what part of your brain is confused, is this your working memory because processing is hard, or is this your long-term memory because you lack the right knowledge, then you can also come to a better solution. So that's the way in which my book contextualizes cognitive science specifically for the problems that professional programmers run into every other day, being confronted with code that is not easy to read.
So you mentioned that just trying to, not everybody might know the difference between, say, short-term memory and working memory. Are you able to provide kind of a quick distinction between that for our listeners and for myself?
Absolutely. So short-term memory is where you remember something. So if I read a phone number to you on the phone, let's say it's a 515437, you are remembering that in your short-term memory. The working memory is your short-term memory applied to a problem. So if I ask you to add 515 and 487, so it's the same numbers, but if you have to add them together or multiply them, then this is your working memory. So when you're applying your short-term memory, doing something, a simple way to say what we say in the book as well, if you are thinking about something rather than remembering something, then you are using your working memory.
Interesting. Okay, great. Do you say that there's with your book, there's a target audience in some ways? Do you feel like this will be really effective for, say, junior developers, people that are aspiring to become full-time programmers at some point in their career, or maybe they're in school, or senior developers? What's your kind of take on that?
Yeah, so it depends a bit. The book has 4 different parts, and the first few chapters are very much about individual confusion. So I don't think it's good for people that want to become programmers, because the examples are very much, they rely on a little bit of programming knowledge. So if I say you're confused about code because you don't know the domain words, it is nice if you have had that experience before. So I would say people with a little bit of experience in being confused, that you can really connect these scenarios to actual things that have happened to you. So that the beginning of the book is sort of junior, media plus. But then the end of the book is very much about collaboration, about not just managing your own confusion, but also managing the confusion of people in your team, junior people. There's a specific chapter about onboarding people into a code base. So if you are onboarding someone into your code base, then you really have this problem because you know everything. And what you sometimes do, I sometimes do this if I'm onboarding undergrads into a project, is they come in and you're like this vomit of knowledge, right? So here's everything you need to know about the code base. And you keep piling knowledge, and then you see, they lean backwards and their eyes start to be a little bit like blank. And then after 2 hours, it's like, any questions? They're like, no. The final chapters are a bit more geared towards people that are at such a level that they aren't just struggling with their own confusion. They're also struggling with other people coming into their code bases, into their projects, not knowing where to start, not knowing how to get going.
Hi there. Do you know someone who might be looking for assistance with their Ruby on Rails application? Planet Argon would love to meet them. We're offering a $1,000 referral bonus. Send someone our way, and if they sign up for services with Planet Argon, we'll give them a $1,000 discount. And in return, you'll get a check for $1,000 in the mail, just for knowing the right person. Hop on over to planetargon.com/referrals for more information and to refer someone our way. That's planetargon.com/referrals. Thanks.
For those listening, going into that type of scenario where you're the person being onboarded, do you have any advice for them on how to go in there with some sort of approach that can help direct the person that's going to be, or the people that are going to be onboarding there. So it's not you're not depending just on them having a really, really clear process, because not everybody, I'm not going to assume that everybody listening right now is going to be preparing for onboarding someone else, but I think a lot of people are going to get onboarded to something at some point, and how can they play a role in making sure that they can retain as much as they can, but also knowing that like you can only remember so much when someone just vomits a bunch of background on something.
Yeah, that's a great question. So I think feedback is really the key there. Of course, if you are more junior, it can sometimes be hard to give feedback. But when I am onboarded or when someone explains code to me, I often go like, okay, wait, 1 second. Let me make sure that I understood what you just said. And as I said, if there's too much of a power balance, then the cultural difference, also gender differences. Not everyone might be comfortable with stopping the more senior person, but if you can do that, then that is a very good strategy where you say, okay, 1 second. Let me rephrase that. So did you just say this and this and this? And of course, if you are a good onboarder, you will do that. You will make sure that there are these moments in which you can check. This is the advice in my book, one of the advices. Check that they really understand. But this is something you can also do on the other side, where you summarize what you just heard. If the space is there, make some notes of these summaries. If the onboarder says, yeah, that's indeed how it is, make some notes. Record the meeting if possible, so you can listen to it. And now we do so many things online. It's a little bit easier. Normally it would be a bit weird if you say, oh, let me bring my iPhone. But now with online meetings, it's a little bit easier to, of course, ask people for permission. But it's a little bit easier, feels less intrusive to record such a meeting. And also, where possible, be prepared. So if you know that this company is working, again, let's say in shipping, read up on what are the important domain concepts. If you already have access to the code, there are some exercises in the book where for example, one of the exercises is take a class, write down all the method names, write down all the identifier names separately on a sheet of paper, and try to see, okay, what do I know about order, shipment, ship, truck, or some random things that might occur in a shipping code base. Write down for yourself, what do I already know about these domain concepts? Check for definition. If there are words where you're not really sure what exactly does it mean, you can already start your project repository, your knowledge base of what you know about the code base. And if it's a programming language that you are not super familiar with or you haven't worked on for a while, train yourself in that specific programming language also before the meeting, so that the programming language doesn't get in the way. Right. Those are things you can do from this. I like this question because that's not really the perspective that chapter takes. That's really about the other side. But it wouldn't be terrible to have this little extra information from the other side. This is what you can also do to prepare yourself for being onboarded.
I think sometimes I think that, say, a consultant or freelancer going in to help out a team for a period, or if you're just a new member of a new team, I think we sometimes assume going into those scenarios that these people know everything. Sometimes they don't know everything either, right? And so it's I think having a little bit more control over how you're going to absorb and retain information about, so the domain and the infrastructure that you're going to be joining and helping improve upon. And I've also noticed that I feel like the handful of times that I can recall where we had someone come in to, say, work at my company, I always remember the people that seem to be taking notes more, seem to be thinking through, contributing back to the documentation, like, oh, they're getting it. And then the other people are kind of like, I think they might be getting it. They said they're nodding their head and said they have no questions, but we don't know yet, right? Until we see how they're able to start wrapping their head around things. So I'm always like, it's such an I'm not saying that everybody should go into a scenario, always take take notes and stuff, but I would encourage that to at least know that you can be more than just just listen to someone explain things and hope that everything's going to retain. I'm not a scientist, so I don't know if that's actually helpful in any way, if to like writing things down or, having like your own like little note-taking process or something. Is there any science around how that helps reinforce things?
Yeah, so that isn't really so much my area of expertise, but I think there's some research that says actually, sadly, that if you take notes, you'll remember less because your brain thinks, oh, this is written down. Of course, that isn't a reason not to take notes. That is a reason to revisit your notes because, as you said, writing down notes isn't just something you only do for your own memory. That's also something you can contribute back to the code base. And actually, there are some things we do with students that also work very well in this scenario. So sometimes with students, I specifically say, if you haven't written this and this down, these are the important parts. If you haven't written this down, do this now. So if you see people that aren't making notes, you can try to coach them, saying, okay, here are some important things. Maybe you want to write this down, because this is what's in the book as well, that a beginner, not a beginning programmer, but a beginner in your code base will be just overwhelmed by all the knowledge. So they might not have processing power left to think, okay, what are the most important things? So something like summarizing the most important things is something that you should do as an onboarder, because it's likely that the newcomer is so overwhelmed with all the new concepts, and maybe it's a new programming language or a new IDE, or everything can be new, so that they're not also thinking, okay, what is the most relevant information? They're like, okay, let me remember everything. And then they might focus on the not so important parts. So that's something that you can do as well. And what I also often do in a classroom, if I've explained something at the end of the lecture, I ask a bunch of students to name some highlights. It's like, okay, what for you? What was a highlight? What are you going to take away from this lecture? And if you do that with a bunch of people, then you get a quite complete picture of the whole meeting, because all the students will remember different things, because students do have different prior knowledge, they have different interests. That's also something you can do in a meeting. In addition to having proper notes, you can do a round of, not a round of, are there any questions, but a round of, okay, what are you going to take away from this meeting? And maybe everyone takes away different things, but then together you have a quite complete summary. So that's, if you are onboarding a group of people at the same time, you can definitely ask all of them what their biggest takeaway was. And then together, they might only focus on small things, but together they might form a more complete picture. And also, if none of them have repeated back to you the thing that you think is most important, that's probably something you should add at that point in time.
I think that's some really good advice there. I'm now thinking about, I have a meeting in about 45 minutes from now, and I'm like, ooh, I'm gonna sneak that into my conversation. So thank you for that. I got some free advice there already. In the book, you cite some research around from 2017 where it indicates that nearly 60% of a programmer's software programmer's time is spent trying to understand code versus saying, I'm assuming the other 40% is producing, writing, changing code or something.
Yeah, testing, running, yeah.
So it's like one of those stats that I think sounds really surprising when you first read that, because you're like, well, we're programmers and we're writing new code all the time. We have these things called editors. But I think it also, I heard something similar from a previous guest when they referenced something similar, and I think it was like this, but that also makes sense. I mean, like, it's not like I'm not surprised by that number, I suppose. It's just not something I think we as an industry talk a lot about, especially when we're training people to become programmers. And my assumption is I didn't go through a normal computer science program in that capacity. But I'm curious, like, what do you think developers should be doing more to think about retaining information in this sort of capacity with these exercises? Or is the goal to reduce that 60% as an industry? Or is it just to make that more useful or be better spent in that time?
Yeah, that's a great question. So I think there's definitely some reduction possible. So there's not reduction possible if you work in a team and overnight people have added features, and then the next day or the next time you're working on the code, you will have to form a new mental model. Because I think that is what's key here. Why developers read code is because they need to form a mental model of how does everything work. So some people really like visualize this as they have a UML diagram in their imagination, or another way of a swim lanes diagram, another way of visualizing the code. So the reason people read code is because they have to form or form again a new mental model. And if other people are making changes to the code, then this is inevitable that every time you have to think, oh no, this is here. Oh, okay. Oh, okay. Now this is this. But if the code is relatively stable, or if you're with a smaller group of maintainers, or maybe you're the sole maintainer, then also very often I definitely spend some time on reading my own code. I was like, who made it? Why is this? Oh, now I remember. And I think that's the key is, and this is really hard. So again, I'm talking to me also here. I think the key is that once you have this aha moment, you're like, oh yeah. So let me give an example of a code base that I was working on. We are parsing code. I made a programming language, and we're parsing code and we're transpiling it to Python. And we do this in a 2-step way. So first we get an AST and then we transform the AST. And as I was trying to reread this code again, I was like, so why is this a 2-step model? Why don't we do just everything in one step? And that is of course, you continue. You're like, oh yeah, of course, we do this because it's easier, because actually the AST of our language is kind of similar to Python, so the transformation is not so hard. The moment where you think, oh, this is why we did it. It is tempting, it is so tempting to then start programming, because you have this mental model and now you are good to go. You are ready to be in this flow state of being productive. But if you have a little bit of self-restraint, and at that point you can think, okay, this is what I need to write down. Because the moment you know it, you can write it down. And also you can write down what led you to understand it again. So then this would be the point where you go into your class, in your class definition, or in a README, doesn't matter where you put it, where you write down, hello, dear reader, Felienne of the future. This is, welcome to this code base. This is a 2-step model and we do it for this and this reason. That, I think, is one of the things you can do once you have the mental model, retain it. And this can be a comment sometimes also, this is what we talk about in the book as well, diagrams can be really helpful. So there are some diagrams that you can generate automatically with like UML architecture tools, but also just a handwritten note, something that you scribble on a piece of paper. It is so easy now. You take a picture, you can just drop your picture into GitHub, right? This is my random mental model of the code, clean it up a little bit and put it there. So once you've formed this mental model, that is something that really takes effort. And if you can store that mental model separate from the code in a comment, in a diagram, in a README document, then you will benefit from that in the long run. But as I said, this is hard because that is the moment that you can also start programming, which arguably is way more fun than documenting your mental processes.
You know, in preparing for our conversation, I was watching a video that you had given called "Why Should You Talk to Your Computer," where you shared a story about how you first started to learn to code with a book on writing a computer game. I actually had that. I don't think I had that same book, but I had a very similar start as well. But I actually found myself really struggling with it at the time when I was 6 years old or something like that, because my dad gave me this book. He's like, if you retype the things that are inside this book and run it, you can then play the game. And I was like, well, this is weird. Like, why would I spend the time to do that if someone else already wrote it? In retrospect, I'm like, was he teaching me how to type, or he actually thought I would be interested in writing software? But there was never a conversation around, all right, so if you do this, we can run it, and then you can go and start making changes to it to make it your own game, customize it in some ways. And so I'll never know if that would have helped. Like, I never thought that I wanted to become a software programmer because of that. And so anyways, I was thinking of when I was watching your talk, you were talking about your own story there. Do you feel like now that you've reflecting on teaching kids how to program in the past, how do you approach that type of thing? Am I wrong in thinking that if like there had been maybe more of like, we can customize it a bit more and then make it yours versus just being like retyping something and trying to like remember what the purpose of this was?
Yeah, so I think you're very right. And I think many of the resources programming for kids, and this is, I think, as true today as it was in the 80s, assume that kids want to learn programming. So many of those resources are written by programmers. And they assume that kids want to learn programming. And also there's this culture that in general, in programming, you have to like programming. You have to like the act of programming. You shouldn't be too much in love with what you can do. And if you compare that to like playing guitar, there's some kids that are interested in the guitar because it's a technical thing. Oh, why does this sound slightly different if I put my finger here? But many kids are interested in playing guitar because they can join a band. It is clear what you can achieve if you can play the guitar. You can be you can be a solo artist, you can be a singer-songwriter, or you can be in a rock band or in a blues band. This dot on the horizon is pretty clear. And I think that dot on the horizon that your dad maybe failed to paint, I think that's not him, that's also all the lesson materials, always assume that the programming itself is fun. And we do such a crappy job of showing why it's fun. And I also did that. Like, I also say, hello, children, you know what we're going to do? Print all the prime numbers.
Cool.
Woohoo! Exciting! Did you know there are infinitely many? This is going to be an exciting afternoon. But if as a child you don't know what programming can bring you, like you said, I don't know if I can make my own game, or can I use programming to create a story or an app or whatever. If you assume that kids already want to learn programming, then the kids that don't know yet if they like programming, or maybe they don't like programming that much, but they do like the idea of being able to make their own game, and that is a pathway into programming. I think you're very right that this often is an assumption that kids want to learn programming. Some kids do, but some kids don't like it at all. And some kids might like it if we just told them what they could achieve at the end of it.
It feels like it has to be like a passion of yours. Like I do not have writing software, writing open source stuff is not my passion. It's a tool that I was able to pick up and figure out how to build things for clients, how to like build things for companies, organizations, or to build my band's website. Like I learned these things so that I can have some sort of output of it. It was just a gateway to get there. It was the thing I couldn't afford to pay someone else to do. So I'll figure out how to do this so that I can create the thing, the output of it. And I always wonder how much there's this intersection of people that are really passionate and excited about programming or writing and talking about it all the time. And then there's everybody that's joining and they're like, oh, this could be an interesting career. Oh, do I belong here? Because I don't seem to love it.
It's such an exploitative way of thinking. And imagine if you transfer that to another profession. And like we say, oh, you really need to work on open source projects in the weekend, because if you're not a passionate developer, then you don't belong here. You imagine like, oh, if you're a passionate surgeon, then on Saturday night you're going to operate on your hamster because don't you enjoy surgery? Why don't you do it on Saturday evenings? This is wicked, right? There are so many professions where it's just 9 to 5, it's just your job, and you can enjoy your job and still have reasonable work-life balance. And another point, going back to my book, of course, another point that I make there is that probably writing more code than already your job isn't even such an effective way of learning. Again, comparing this to music, if you want to get better at playing the guitar, what you're not going to do is just play songs. And then in the weekend, you will play more songs in a different guitar, in a different musical style or something. No, if you want to get better, what you do is deliberate practice. You're like, oh, I want to get better at, I don't play the guitar, but I want to get better at A major or something. So you deliberately practice that many times. And what you maybe also do is listen to guitar players that you think are really good. And you think, oh, what do they do there? Oh, let me listen to that song again. What happens there? So just the idea that apart from the fact that it's kind of weird that we expect people to work for 40 hours on the job and then still like it for 40 hours more, it's also not even so effective if you're just writing more source code in a weekend. Then you're not magically going to get better if you don't focus on getting better. Probably you'll get a little bit better. It's just not a very effective way to get a lot better. Just do more of the same thing you already do 9 to 5, Monday to Friday.
We'll be back with our interview with Felienne in just a moment. Hi, it's me, Robby. I want to take a quick moment just to say thank you for making time to listen to the Maintainable Software Podcast. If you're finding these discussions valuable, please consider sharing a link amongst your peers. Drop a link in Slack, Discord, Twitter, LinkedIn, wherever you kids are hanging out these days. And a writing review on Apple Podcasts. All of these things help contribute to spreading the word. Also, do you know someone in the industry that I should be interviewing with on Maintainable? Shoot me an email to Robby with a Y at maintainable.fm and state your case. And now, let's get back to our interview with Dr. Felienne Hermans. You talked about mob programming and like writing things down when you have that aha moment. I'm also curious about when you're trying to debug a situation. So I know a number of programmers. I don't actually have a rubber duck on my desk, but people talk about rubber ducking as this, where it's like the process of kind of reading line by line what you're looking at, explaining it to someone in the room, or a weird creature on your desk for whatever reason, a toy. That helps just by talking out loud. Why do you believe this approach seems to work so well, or is that actually maybe not the case?
No, I do think it works well. And I think it has something to do with what we talked about a little bit earlier, that this is making your mental model, making your assumptions explicit. So doing that for me, note-taking works a bit better than speaking loud. But for some people, just literally saying it to their rubber ducky or imagining they're saying it in their inner voice. You are making concrete what your assumptions are. You're like, oh, hello, rubber ducky. I don't understand why this test is failing. Okay, so what is happening? This test is failing. Okay. I don't understand why this method is being called. Oh, okay. So you sort of go through you slow down your mental process. So that's why it works, because you are making your mental model that you are probably recreating from reading code. You're making it explicit in the form of natural language if you're speaking to a ducky, but this can also be in the form of a written language or diagrams if you write it down on paper or on a whiteboard or whatever.
So a couple quick last things I wanted to touch on with you. One, you're also one of the hosts of the Software Engineering Radio podcast. What prompted you to be part of it?
I think it was just access to famous people that I could interview, that I could easily get an hour of time with. I think that was my main reason, that it's such a good way. I mean, I guess you know this as a podcast host. It's such a good way to just interact with people, because normally people that we have on the show, they wouldn't have an hour to chat with me just for chatting with me. But now, last week, I interviewed the founder of Fauna. This is a distributed database. And we spent a whole hour and I was learning so much. I was making notes and asking questions like, oh, but why do you design it this way? So it's just this access to people that are interesting and that have built interesting stuff is a very effective way of learning. And then it's in your schedule, right? You invite people and then you have to show up. So you don't, because of course we all know this, like, oh, this is an interesting book. I could have read a book about the distributed database design, but then I never have time to read a book. But if the interview is in my schedule, I have to go. So I think that was what made me really interested in it.
I think it's interesting. Not that the world needs necessarily tons more podcasters, but also everybody should start a podcast if they feel like that's a good way to get access to and have really interesting conversations with different people. I was curious, like what you felt like you were getting out of it on a kind of a day-to-day level. And it sounds like just being able to have access to talk to people and then like learn a little bit each time and that's what I get out of it. This is the 98th person, you're the 98th guest I've had now. And so I'm like, wow, I can't believe I've had that many conversations with that many like really, really smart, educated, thoughtful people in the industry that I outside of just like the few people I get to interact with on a daily basis within my organization. So, but then also knowing that I get to share that with the community and they get to hear those conversations too. So hopefully that can be an interesting round. I don't know where I'm going with this. I'm kind of getting a little rambly here, but I thought I would just want to point out that you are you're one of the hosts of that podcast. We'll include links to that in the show notes for people as well. And they should definitely subscribe to Feliene's podcast. So a couple questions. So for those listening who might have heard from other experienced programmers that they just keep pushing through the struggles presented by day-to-day software challenges, it's part of the journey. That if they just stick with it, it will help you get better. Or you have to learn to appreciate all this fuzzy unknowns and the confusion that seems to pop up when we're working on code. Do you agree with this sentiment?
Yes, so mainly no. So of course, yes, programming is hard, but everything is hard. It is like, playing the guitar or running a marathon. Many things in life are hard. And I think if we compare our community to other communities, then we emphasize the being hard a bit too much. Also, again, looking at books for kids, programming books for kids will really literally say programming is hard and it will be frustrating, which is true, but if you have a book, Soccer for Kids, The Guitar for Kids, certainly it will not say playing the guitar is hard. It will say try your best, and if you practice a lot, you also can be the next Lionel Messi, right? So this emphasis of practice is really different from the emphasis that we have on the struggle. And in many cases also I think some of the struggle is necessary, but some of the struggle is also because, for example, in teaching programming, whether that is boot camps or whether that is university curriculum or high school curriculum, we never practice reading code. Everything we do, and I am as guilty as that being an educator as the next person, I have also thought so often in a way saying, hey, this is a for loop, this is a variable. Okay, now kids, go reverse a linked list or print all the prime numbers. The more emphasis we would have on practicing reading code in school, in university, practicing this within a company, if you do something more, you will get better at it. And if you deliberately practice something, you will get better at it. So this time we spend on reading, a little bit is needed because you say, as I said, there's churn in the code, but a lot of that also is just we don't practice. We don't have strategies for what is your strategy for reading code, right? You look at the code, you're like, wow, what is this? This is confusing. Let me try again. the strategies that, of course, also I describe in the book, if you would just practice reading more, it's still hard, but it would get easier. Imagine how proficient you are at reading natural language. This isn't because it was so hard, right? This is because you practiced so many times. They didn't say to you in grade 1, hey, this is the alphabet. Now here's Shakespeare. No, you practiced so often reading small sentences and practicing or reading maybe poetry in high school. So if you practice a bit more, then it would get easier. And then part of the struggle, we don't need to celebrate. We don't need to say, oh, it's so hard. Just stick for 2 hours. You would be like, I have a strategy. I could make a state table or scribble on the code, or I could execute the code, or I could run some tests. You have a plethora of strategies you could try, and then a little bit of the frustration will probably go down. And then that means we can celebrate it a little bit less, which also is more inclusive. Because again, coming back to why do people want to program? If kids know that they want to become programmers and they struggle a bit, they're like, yeah, okay, this is part of the game. But imagine being a kid that like you were when you were small. You don't really know if you should like programming. You don't know yet what programming can do for you. And then you forget a space, or you misplace a space, and then Python yells at you, syntax error, unexpected EOL. And then you're like, ooh, this is hard. And then the books or the teachers say, oh, but this is just part of the game. Well, what do you think? What? You should just try again. It's like run the code again. Yeah, it's the same error. No, we should explain to kids. We should make the error messages better, but also explain to kids, okay, this is what happens. This is why that happened. Practice syntax, practice all these small skills, instead of saying, oh yeah, well, that's terrible. Exactly as terrible as it should be.
Well, I think that's a good thing to end on there. And as far as definitely pick up Felienne's book, I think you can learn a lot from that. And I'll include links to that in the show notes for everybody. And we'll also be giving out a couple of free copies of that, thanks to the publishers. My last few questions. One of them I always like to ask people, because I feel like it's actually something that's very telling of whether or not people can think of something outside of this. So what non-software development / technical book do you find yourself recommending to people on a regular basis?
Oh, that's a great question. I can only think of books I like that are about, books that I like that are about programming, or like novels that I really like. Maybe this is about running, because if I don't talk about programming, I'll talk about running. I really like this book, What I Talk About When I Talk About Running, by Murakami, because it's about running, and if you're a long distance runner, you will definitely recognize it. But it's also about mental strength and resilience and getting to know yourself. So that is maybe a book. It's especially nice if you're an ultra marathoner, but it's also nice for other people.
I'll have to check that one out. I've read a number of his other books, and I keep forgetting that's on the list of ones to pick up. So as someone I'm not a ultra marathoner, I do run a lot now. That was one thing I've been able to do during the pandemic, was like, oh, I guess I can go run. I can just run away from people for 45 minutes and feel pretty good about myself on a regular basis. So where can listeners best follow your thoughts on software programming and what programmers' brains are doing online?
So where I update most is Twitter, and my Twitter is just my first name, @Felienne, so that's easy. My website, where I regularly blog, is also a good source to read more lengthy pieces that I write, and you can also read there about all the scientific work that I do. I tend to publish most of my papers on my blog as well, and my blog is also easy. It's just my first name.com, felienne.com. So that would be the two places where you can read most.
Well, excellent. Well, it's been such a delight having you join us today on Maintainable, Felienne. Thank you so much for talking shop with us.
Thanks for having me.